Greetings everyone, welcome to the most comprehensive, technical, detailed, and yet still beginner-friendly Stable Diffusion text embeddings, also known as Textual Inversion training tutorial. In this video, I am going to cover all of the topics that you see here and more. Currently, I am hovering my mouse over there. You can pause the video and check them out if you wish. Also, you see here the training dataset we used and here the textual embedding used results. Let's start by quickly introducing what is textual inversion and its officially released academic paper. If you are interested in reading this article, so you can open the link and read it. I am also going to show some of the important parts of the this article when we are going to use them. I will explain through the article. So to do training, we are going to use Automatic1111 Web UI. If you don't know how to install and set up the Automatic1111 Web UI, I already have a video for that on my channel, easiest way to install and run Stable Diffusion Web UI. Also, I have another video how to use Stable Diffusion version 2.1 and different models. So I am going to use specific version of the Automatic1111 Web UI. It is constantly getting updated and therefore it is constantly getting broken. And you are asking me that which version did you use? I am going to use this specific version, this commit, because after bump graduate to 3.16 it has given me a lot of errors. So how am I going to use this specific version? To use specific version, I am going to clone it with git bash. If you didn't still install git bash, you can install it by using Google. Just type git bash to Google. You can download from this website and install it. It is so easy to install. First, I am going to select the folder where I want to clone my Automatic1111 Web UI. I am entering my F drive and in here I am generating a new folder with right click new folder. Let's give it a name as tutorial web UI. Okay, then we will move inside this folder in our git bash window. To do that, type cd f colon. Now we are in the F drive, then cd put a quotation mark like this and hit enter. Now we are inside this folder. Now we can clone Automatic1111 with git clone and copy the URL from here like this and paste it into here. Right click paste and it will clone it. Okay, it is cloned inside this folder, so I will enter there cd as top and it will be automatically completed like this and hit enter. Now we will check out the certain version from here. Let me show you again. Click the commits from here and here I am moving to the commit that I want. Enable progress bar without gallery. This is the commit ID. I will also put this into the description of the video. Then we are going to do git checkout like this and right click paste. Now we are into that commit and we are using the that specific version inside our folder. So before starting setup, I am copy pasting this webui user.bat because I am going to add my command line arguments to here. Okay, right click the copy and edit and let me zoom in. Copy paste. So I am going to use xformers, no half and disable safe unpickle. So how did I come up with these command line arguments? Xformers going to increase your speed significantly and reduce the VRAM usage of your graphic card. No half is necessary for xformers to work correctly when you are using SD 1.5 or 2.1 versions, and disable safe unpickle. According to the Web UI documentation, you see the URL here, command line arguments and settings. Disable checking PyTorch models for malicious code. Why I am using this? Because if you train your model on Google Colab, sometimes it is not working. This is not necessary, but I am just using it and I am not downloading any model without knowing it. Okay, then we save and run. Then we are going to get our fresh installation. Okay, like this. It will install all necessary things, and you see, let me zoom in. It is using Python 3.10.8 version. By the way, you have to have installed Python correctly for this to install. It is also showing the commit hash that I am using like this. I also need to put my Stable Diffusion models into the models folder. So let's open it, open the Stable Diffusion folder, copy paste from my previous download. And one another thing is I am going to use the latest VIA file that I have downloaded from the internet, which I am going to show you right now. So where do we put this VIA file? Go to the Stable Diffusion Web UI, and in here you will see VIA files folder. It is not generated yet. It is inside the models folder, and inside here VIA, and this is the VIA file. Why we are using this VIA file? Because it is improving generation of person images. And now let me show the link. Okay, this is the link of the VIA file. This is the latest version of VIA file. Just click the CKPT file from here and click the download button. I will also put the link of this into the description. So if you are wondering the technical description, technical details of the VIA files, there is a long explanation in here in this thread. I will also put the link of this thread into this description of the video. And there is a shorter description which I like it. Image generation is done in a compressed representation. The VIA takes the compressed results and turn them into full-sized images. ST comes with a VIA already, but certain models may supply a custom VIA that works better for that model. And ST 1.5 version model is not using the latest VIA file. Therefore, we are downloading this and putting that into our folder. ST 2.1 version is using the latest VIA file. And which ST 1.5 version model I am using? I am using the 1.5 Pronode CKPT. And where did I download it? I have downloaded it from this URL, and we are using the Pronode CKPT because it is better for training than EMMA only file, which you see is lesser in size. By the way, the things I am going to show in this video can be applied to any model such as Protogen or ST 2.1 version. Actually, I have made experiments on Protogen training as well, and I will show the results of that to you. Okay, the fresh installation has been completed, no errors, and these are the messages displayed. And it has started on this URL, and I have already opened it. You can copy and paste this URL in my browser. So currently it has selected by default the Protogen, and I am going to make this tutorial on version 1.5 Pronode, the official version. Okay, before starting training, I am going to first going to show you the settings that we need. Go to the training tab in here and check this checkbox, move via, and click to RAM when training. This requires a lot of RAM. Actually, I have 64 GB, and if you have checked this, it will reduce to VRAM, which is the GPU RAM, which is our more limited RAM. Then you can also check this, turn on pin memory for data loader. This makes training slightly faster but increase memory usage. I think this is increasing the RAM usage, not VRAM usage. So you can test this. In other videos, you will see that check this checkbox, use cross attention optimizations while training. This will significantly increase your training speed and reduce the VRAM usage. However, it is also significantly reducing your training success. So if your graphic card can do training without checking this out, do not check this, because it will reduce your training success, and it will reduce your learning rate. How do I know this? According to the Vlad Mandik from GitHub, this is causing a lot of problems. He has opened a bug topic on the Stable Diffusion Web UI issues, and he says that this is causing a lot of problems. Let me show you. He says that when he disabled cross attention for training and rerun exactly same settings, the results are perfect, and I can verify this. So do not check this if your graphic card can run it. There is also one more settings that we are going to set. Save an SCV containing the loss to log directory every n steps. So I am going to make this one. Why? Because I will show you how we are going to use this during the training. Then go to the apply settings. Okay, then reload UI. Okay, settings were saved and UI is reloaded. Now go to the train tab. Okay, first of all, we are going to give a name to our embedding. The name is not important at all, so you can give it any name. This will be used to activate our embedding. Okay, so I am going to give it a name as training example. It can be any character length. It won't affect your results or token count. Initialization text. Now, what does this mean? For example, you are teaching a face and you want it to be similar to Brad Pitt. Then you can type Brad Pitt. So what does this mean actually? To show you that, first we are going to install an extension. Go to the available, load from, and in here type embed into your search bar, and you will see Embedding-inspector. This is an extremely useful extension, and let's install it. Okay, the extension has been installed, so let's just restart with this. Okay, now we can see the embedding inspector. So everything in the stable diffusion is composed by tokens. What does that mean? You can think tokens as keywords, but not exactly like that. For example, when we type cat and click inspect, the cat is a single token and it has an embedding ID and it has weights. So every token has numerical weights like this, and when we do training with embeddings, actually we are going to generate a new vector that doesn't exist in the stable diffusion. We are going to do training on that. So when you set initialization text like this, by the way, it is going to generate a vector with the weights of this. However, this is a two token. How do I know? Go to the embedding inspector and type Brad. So you see Brad is a single token. It has weights, and let's type Pete. And Pete is also another token and it has also vector. So these weights will be assigned initially to our new vector. However, we have to use at least two vectors, otherwise we wouldn't be able to get two vectors. So if we start our training with Brad Pitt, our first initial weights will be according to the Brad Pitt, and our model will learn upon that. Is this good? If your face is very similar to Brad Pitt, yes, but if it is not, no. So Shondoit from the automatic community has made an extensive experimentation, and he found that starting with zero initialization text as empty, so we will start with zeroed vectors, is performing better than starting with for example star, because star is also another token, and you can see it from here. Just type star here. It is just some vectors like this. So starting with empty vectors is better. And now the number of vectors per token. So every token has a vector in the stable diffusion, and you may wonder how many tokens there are. To find out that, we are going to check out the clip with large patch. So in here you will see tokenizer JSON. Yes, inside this JSON file all of the tokens are listed. So you see, let me show, there is word IDs and words themselves. Like here, you say yes. So the list is starting from here. So each one of these are tokens, and it goes to the bottom like this. For example, sickle, who's, lamo, etor, finity. So these are all of the tokens, all of the embeddings that the Stable Diffusion contains. If you wonder how many there are exactly, there are exactly 49 408 tokens, and each contain one vector. For st1.x versions it is 768 vector size, and for st2 version it is 1024. So when we do embedding inspector, you see it is showing the vector. So everything is composed by numerical weights, and they are being used by the machine learning algorithms to do inference. And so also every prompt we type is getting into tokenized, and I will also show that tokenization right now before we start. To do that, go to the available tab, load here, and search for token, and you will see there is Tokenizer, like Tokenizer extension. Just install it, restart the UI, and now you will see Tokenizer. So type your prompt here and see how it is getting tokenized. So let's say I am going to use this kind of prompt. It is showing in the web UI that 58 tokens are being used, and we are limited to 75 tokens. But we are not using 58 words here. If you count the number of words, it is not 58. So let's copy this and go to the tokenizer, paste it and tokenize, and now it is showing all of the tokenization. So the face is a single token with ID of 1810, photo is single token, off is single token. And let's see, okay, so the art station is 2 tokens. It is art and station. Commas are also 1 tokens, as you can see. And let's see if there is any other being tokenized into sub tokens. Okay, photorealistic is also 2 tokens, and art station is 2 tokens. So this is how tokenization works. Each of these tokens have their own vectors, and you can see their weights from embedding inspector. However, it is not very useful because these numbers doesn't mean anything individually, but in the bigger scheme they are working very well with the machine learning algorithms. Machine learning is all about weights. Also, in the official paper of textual inversion, on the page 4, you see they are showing a photo of a star, which is our embedding name. So you see there is a tokenizer and token IDs, and they have vectors like this. So it is all about vectors and their weights. Okay, now we can return to train tab. Now we have idea of our tokenization. So let's give a name as tutorial training. You can give this any name. This will be activation. Initialization text, I am just leaving it empty to obtain best results. So our vectors will start with 0. Let's say you are training a bulldog image, so you can start with bulldog weights. So it will make your it may make your training better. However, for faces, since we are training a new face that the database has no idea, I think leaving it as empty is better. So number of vectors. Now you know that each token has 1 vector, which means that when we type Brad Pitt, only 2 vectors are used for that. So all of the Brad Pitt images are saved in the Stable Diffusion model with just 2 vectors, which means that 2 vectors is a good number of is a good number for our face training or for our subjects training. I also have made a lot of experiments with 1 vector, 2 vector, 3 vector, 4 vector, and I have found that 2 vectors are working best. However, this is based on my training dataset. You can also try 1, 2, 3, 4, 5, and you will see that the quality is decreasing as you increase the number of vectors. Also in the official paper, the researchers have used up to 3 vectors. You see extended latent spaces. This is the number of vector count that is derived from the official paper, and they have used up to 3. You see detonated 2 word and 3 word. But it is up to you to do experimentation, and I am going to use 2. If you write override alt embedding, it will override if there is embedding like this. So let's click create embedding, and it is created. So where it is saved, go to your folder, installation folder, and in here you will see embeddings, and in here we can see already our embedding is composed. Then let's go to the preprocess images. So this is a generic tab of web UI. It provides you to crop images, create flipped copies, split oversized images, autofocal point crop, use blip for caption, use DreamBooth for captioning. There is source directory and destination directory. So I have a folder like this for experimentation and showing you. I am copying it, its address like this, and pasting it in here as source, and I am going to give it a destination directory like A1. They are going to be auto resized and cropped. So let's check this mark, create flipped copies. By the way, for faces I am not suggesting to use this. It is not improving quality. You can also split oversized images, but this doesn't make sense for faces. Autofocal point, yes, let's just also click that. Use blip for caption, so it will use blip algorithm for captioning. This is better for real images, and DreamBooth is better for, I think, anime images. Okay, and then just let's click Preprocess. By the way, why we are doing 512 and 512? Because version 1.5, Stable Diffusion version 1.5 is based on 512 and 512 pixels. If you use version 2.1 Stable Diffusion, then it has both 512 pixel and 768 pixels. So you need to process images based on the model native resolution, based on the model that you are going to do training. In the training tab, it will use the selected model here, so be careful with that. And when the first time when you do pre-processing, it is downloading the necessary files as usual. Okay, the processing has been finished. Let's open the processed folder from pictures and A2 folder, A1 folder, and now you see there are flipped copies, and they were automatically cropped to 512 and 512 pixels, and there are also descriptions generated by the blip. When you open the descriptions, you will see like this: a man standing in front of a metal door in a building with a blue shirt on and black pants. So now we are ready with the process images. We can go to the training tab. In here we are selecting the embedding that we are going to train. Embedding learning rate. There are various let's say discussions on this learning rate, but in the official paper 0.005 is used. Therefore I believe that this is the best learning rate. The gradient clipping is related to HyperNetwork learning rate, HyperNetwork training, so just don't touch it. So the batch size and gradient accumulation size, this is also explained in the official paper. The batch size and gradient accumulation steps will just increase your training speed if you have sufficient amount of VRAM memory. However, make sure that the number of training images can be divided the multiplication of these both numbers. So let's say you have 10 training images, then you can set these as 2 batch size and 5 gradient accumulation, which is 2 multiplied by 5 is equal to 10, or they can be or let's say you have 40 training images, then you can set it as 20 or 10 or 5. It is up to you. However, this will significantly increase your VRAM usage, and let's say the multiplication of these two numbers is equal to 10, then you should also multiply learning rate with 10. Why? Because this requires learning rate to be increased. How do I know that? In the official paper, in the implementation details, they say that they are using 2 graphic cards with batch size of 4. Then they are changing the base learning rate with multiplying by 8. Why? Because 2 graphic cards batch size 4 4 multiplied by 2 is 8, and when you multiply 0.005 with 8, then we obtain 0.04. So be careful with that. If you increase this batch size and gradient accumulation steps, just also make sure that you are increasing the learning rate as well. However, for this tutorial, I am going to use batch size 1 and gradient accumulation steps as 1. Actually, until you obtain good initial results, don't change them. I suggest you. Then you can change them. Then you need to set your training dataset directory. So let's say I am going to use these images, then I am going to set them. Also, there is log directory. So the training logs will be logged in this directory where it is. When we open our installation folder, we will see that there is textual inversion. However, since we still didn't start yet, it is not generated. So when the first time we start, it will be generated. I suggest you to not change this. Okay, prompt template. So what are prompts, templates? Why are they used? Actually, there is not a clear explanation of this in the official paper. When you go to the very bottom, you will see training prompt templates. So these templates are actually derived from here. From my experience, I have a theory that these prompts are used like this. So let's say you are teaching a photo of a person, then this the vectors of these tokens are also used to obtain your target image. So they are helping to reach your target image. This is my theory. So it is using the vector of photo, it is using a vector of a of, or you are teaching a style, then it is using that. So these templates are actually these ones. When you open the prompt template folder, which is in here, let's go to the textual inversion templates, and you will see the template files like this. So let's say when you open subject file words, you will get a list of like this, a photo of name and file words. So the name is the activation name that we have given. It will be treated specially. It will not get turned into a regular token. For example, tutorial training would be tokenized like this if it was not an embedding. Tutorial training, let's click tokenize. You see the tutorial training actually 3 tokens. Tutorial is tokenized like tutor, eal, and training. However, since it will be our special embedding name, therefore it will be treated as with the number of special tokens, and it will be based on the number of vectors per token. We decided if we decide this to take 10, then it will use 10 token space from our prompting. So it will take 10 space in here. However, it will now take only 2 instead of 3 because it will be specially treated. Okay, let's go back to the train tab. So this name is the sorry about that. This name is the name of our embedding name and the file words. So the file words is the description generated here. So basically the prompt for training will become tutorial training, and the file words, let's say it is training for this particular image, it will just get this and append it here, and this will become the final prompt for that image when doing training. So how should we edit this description? You should define the parts that you don't want model to learn. Which parts I don't want model to learn? I don't want model to learn this clothing, these walls, for example, or this item here. So I have to define them as much as possibly. So if I want model to learn glasses, then I need to remove glasses. Okay. And for example, if I want model to learn my smile, I should just remove it. Okay. I want model to learn my face, therefore I can just remove it, and this is so on. However, I am not going to use filewords in this training because I have found that if you pick your training dataset carefully, you don't need to use filewords. So how am I going to do training in this case? I am just going to generate a new text file here, and I will say my special. Okay, let's just open it, and here I am just going to type name. You have to use at least name, otherwise it won't work, it will throw an error, and I am not going to use file words. Also, I am not going to use myself in this training. I am going to use one of my followers. He had sent me his pictures. Let me show you the original pictures he had sent me. Okay, this is the images he had sent me. However, I didn't use all of them. You see the images right now. There are different angles and different backgrounds. When you are doing textual inversion, you should only teach one subject at a time. But if you want to combine multiple subjects, then you can train multiple embeddings, and you can combine all of them when generating images. So which ones I did pick? Let me show you. I have picked these ones. Okay, and now you will notice something here. You see the background is here, is like this. You see green and some noise. Why? Because I don't want model to learn background. So if multiple images containing same background, I am just noising out those backgrounds. And why did it noise out the other backgrounds? Because other backgrounds are different. So you see, in your training dataset, only the subject should be same, and all other things need to be different, like backgrounds, like clothing, and other things. So the training will learn only your subject, in this case the face. It will not learn the background or the clothing. Okay, so let me show the original one. So in the original one, you see this image, and these two images have same backgrounds. So I have edited those same backgrounds with Paint.net, which is a free editing software. You can also edit with Paint. How did I edit it? It is so actually simple and amateur, you may say. So let's set a brush size here, and just, for example, change the color like this. Then I did edit some noise, select it with selection tool, set the tolerance from here, and go to the effects, adjust effects, and in here you will see distort and frosted glass, and when you click it, it will change the appearance. You can also try other distortion. By the way, I am providing these images to you for testing. Let me show you the link. So I have uploaded images into a Google Drive folder, and I am going to put the link of this into the description, so you can download this dataset and do training and see how it performs. Are you able to obtain good results as me? Okay, so I am going to change my training dataset folder from pictures, and I am going to use example training set folder. I am going to set it in my training here. Okay, and I am going to use my prompt template. Just refresh it and go to my special. So what was my special? My special was just only containing name. It is not containing any file descriptions. I have found that this is working great if you optimize your training dataset as like me. you can try both of them. You can try with filewords, and you can try without filewords, and you can see how it is working. Okay, do not resize images because our images are already 512 pixels. Max steps. Now this can be set anything. I will show you a way to understand whether you started overtraining or not. So this can be stay like this. In how many steps we want to save. Okay, this is rather different than epochs in the DreamBooth. If you have watched my DreamBooth videos, so each image is one step and there is no epoch saving here. It is step saving. How many training images I have? I have total 10 images. Therefore, okay, so for 10 epochs we need to set this 100 actually. Okay. So the formula is like this: one epoch equal to number of training images. 10 epoch for 10 training images is 10 multiplied by 10 is 100. So it will be saved every 10 epoch. Save images with embedding in PNG chunks. This will save embedding info in the generated preview images. I will show you. Read parameters from text to image tab when generating preview images. I don't want that, so it will just use the regular prompts that we will see in here. Shuffle text by comma, which means that if you use file words, the words in there will be shuffled when doing training. This can be useful. You can test it out. And drop out text when creating prompts. This means that it will randomly drop the file descriptions, file captions that you have used. This is, I think, percentage based. So if you set it 0.1, it will drop out randomly the 10%, and I am not going to use file words, therefore this will have zero effect. Okay, choose latent sampling method. I also have searched this. In the official paper, random is used. However, one of the community developer proposed deterministic, and he found that deterministic is working best. So choose deterministic. And now we are ready. So we can start training. So I'm going to click train embedding. Okay, training has started, as you can see. And it is displaying the number of epochs and number of steps. It is displaying the iteration. So currently it is 1.30 seconds for per iteration. Why? Because I am recording and it is taking already a lot of GPU power. I have RTX 3060. It has 12 GB of memory. Let me also show you what is taking the memory usage. You see OBS Studio is already using a lot of GPU memory, and also training users, but since they are using different parts of the GPU, I think it is working fine. When we open the performance, we can see that the training is using the 3D part of the GPU and OBS is using the video encode part of the GPU. That is how I am still able to record, but sometimes it is dropping out my voice. I hope that it is currently recording very well. Okay, and I also did some overclocking to my GPU by using MSI Afterburner. I have increased the core clock by 175 and I have increased memory clock by 900. So this boosted my training speed like 10%. You can also do that if you want. I didn't do any core voltage increasing. So it has already generated 2 preview images. Where we are going to find them, let me show you. Now it will be inside textual inversion folder. You see it has just arrived, and when you open it you will see the date of the training, and you will see the name of the embed we are going training, and in here you will see embeddings. This is the checkpoint, so you can use any checkpoint to generate images, and this is the images that it has generated. So this is the first image, and also in image embeddings, this image embedding contains the embedding info. Why this is generated? Because we did check this checkbox. You will see the used prompts here. Since I didn't use any file words and I just used name, it is only using this name as a prompt. And what does that mean? That means that it is only using the vectors we have generated in the beginning to learn our subject, to learn the details of our subject, which is the face. And we have two vectors to learn, and also Brad Pitt is based on the two vectors, so why not we can be also taught to the model with two vectors. Okay, in the 20th epoch we already getting some similarity. Actually I already did the same training, so I already have the trained data, but I am doing recording while training for you again to explain to you better. It also shows here the estimated time for training to be completed. This time is based on 100,000 steps, but we are not going to train that much. Actually, I have found that around 3,000 steps we are getting very good results with the training dataset I have. It will totally depend on the training dataset you have, with how many number of steps you can teach your subject. I will show you the way how to determine which one is best, which checkpoint is best, which number of steps is best. Okay, with 30 epoch we already got a very much similar image. You see, with just 30 epoch we are starting to get very similar images. It is starting to learn our subject very well with just 30 epoch, and when we get over 100 epoch we will get much better quality images. Okay, it has been over 60 steps, 600 steps and over 60 epochs, and we got 6 preview images since we are generating preview images and checkpoints for every 10 epoch. Now I am going to show you how you can determine whether you are overtraining or not with a community developed script. So the script name is Inspect-Embedding-Training. It is hosted on GitHub. It's a public project. I will put the link of this project to the description as well. Every link will be put to the description, so check out the video description. And in here, just click code and download as zip. Okay, it is downloaded. When you open it, you will see Inspect-Embedding-Training Py. Extract this file into your textual inversion and tutorial training as I have shown. So you will see these files there. To extract it, just drag and drop. Why we are extracting it in here? Because we are going to analyze the loss. And so the loss, what is loss? You are always seeing the loss here, the number value is here. Loss is the penalty for a bad prediction. That is, loss is a number indicating how bad the model's prediction was on a single example. If the model's prediction is perfect, the loss is 0. Otherwise, the loss is greater. In our case, we can think that as the model generated image, how likely, how close to our training subjects, training images. So if you get a 0 loss, that means that model is learning very good. Okay, if your loss is too high, that means that your model is not learning. Now with this script we have extracted here, we are going to see the loss. And how are we going to use this script? This script requires torch installation, and the torch is already installed in our web UI folder inside VNV folder, virtual environment, and inside here scripts. So we are going to use the Python exe here. To do that, first copy the path of this, open a notepad file like this. Okay, put quotation marks and just type Python exe like this. Okay, then we are going to get the path of the file. Let me show you. The script file is in this folder, so with quotation marks, just copy and paste it in here and type the script file name like this. Then open a new CMD window by typing like this. Okay, let me some zoom in. Copy and paste the path like this, the code, and just hit enter. And you will see it has generated some info for us: learning rate at step, at loss GPX, vector GPX, and the average vector strength. So let's open our folder in here and we will see the files. When we open the loss file, we are going to see a graph like this. An average loss is below 0.2, which means it is learning very well. Why? As close as it is to 0, it is better. So as close as it is to 1, it is worse. So currently we are able to learn very well. Now I will show you how to determine the overtraining or not. To do that, we are going to add a parameter here, minus folder, and just give the folder of embedding files here. Just copy paste it. Again, do not forget quotation marks, and open a new CMD window. Just copy and paste it, hit enter. It will calculate the average strength of the vectors, and when this strength is over 0.2, that usually means that you started overtraining. How do we know? According to the developer of this script, if the strength of the average strength of the all vectors is greater than 0.2, the embedding starts to become inflexible. That means overtraining. So you will not be able to stylize your trained subject. So you won't be able to get good images like this if you do overtraining, if the strength of the vectors becomes too weak. And what was the vector strength? It was so easy. When we open it, the embedding tab, the Embedding-inspector tab, we were able to see the values of vectors. So this strength means that the average of these values, when the average of these values is over 0.2, that means that you are starting to do overtraining. You need to check this out to determine that. By the way, it is said that the DreamBooth is best to teach faces. And in the official paper of embedding the textual inversion, the authors, the researchers have used all UC objects like this, or they have used training on style. Let me show you. Like here. However, as I have just shown, as I have just demonstrated you, these textual embeddings are also very good, very successful for teaching faces as well. And for objects, of course, it is working very well as well. And for styles, I think the textual inversion, the text embeddings is much better than DreamBooth. So if you want to teach objects or styles, then I suggest you to use textual inversion. Actually, for faces, I think textual inversion of the Automatic1111 is working very well as well. And for DreamBooth, to obtain very good results, you need to merge your learned subject into a new model, which I have shown in my video. So if you use DreamBooth, you should inject your trained subject into a good custom model to obtain very good images. But on textual inversion, you can already obtain very good images. Okay, we are over 170 epoch, and meanwhile training is going on. I will show you the difference of DreamBooth, textual inversion, LoRA and HyperNetworks. One of the community member of Reddit used Excalibur, prepared an infographic like this, and this is very useful. So in DreamBooth, we are modifying the weights of the model itself. So all of the prompt words we use, you already know by now that they all have vectors of them, each of them, and these vectors are getting modified in DreamBooth, all of them. The token we selected for DreamBooth is also getting modified, and in DreamBooth we are not able to add a new vector. We already have to use one of the existing vectors of the model. Therefore, we are selecting one of the existing tokens in the models, such as SKS or OHWX. So in DreamBooth, we are basically altering the model itself. Okay, in textual inversion, we are adding a new token. Actually, this is displayed incorrectly because it is generating a unique new vector which does not exist in the model, and we are modifying the weights of this new vector. So when we set the vector count as 2, it is actually using 2 unique new tokens. So it is modifying 2 vectors. If we set the vector count 10, it is using 10 unique tokens. It is being specially treated. It is adding new 10 vectors, and it is not modifying any of the existing vector of the model. So if we set the vector count to 10, actually when we generate an image in here, it will use 10 vectors. It will use 10 tokens out of 75 tokens we have 75 tokens limit. So this is how it works. Also, if you use 10 vector, you will see that you are getting very bad results for face. I have made tests. Okay, in LoRA, it is this is very similar to the DreamBooth. It is modifying the existing vectors of the model. It is I have found that the LoRA is inferior to the DreamBooth, but it is just using lesser VRAM and it is faster. Therefore, people is choosing that. However, for quality, DreamBooth is better as shown here. And the HyperNetworks doesn't have an official academic paper. I think it is made upon a leaked code, and this is the least successful method. It is the worst quality, so just don't waste time with it. It is so I don't suggest to use it. So in HyperNetworks, the original weights, original vectors of the model is not modified, but at the inference time. Inference means that when you generate an image from text to image, it is inference. They are just getting swapped in. So you see there are some images which are training sample, apply noise, compare, and there is loss. So this is how the model is learning basically. Of course, there are a lot of details. If you are interested in them, you can just read the official paper, but it is very hard to understand and complex things. Okay, we are over 200 epochs, so we have 20 example images. The last one is extremely similar to our official training set, as you can see. So let's also check out our strength of the training vector. So I am just typing, hitting the up arrow in my keyboard, and it is retyping the last executed command, and hit enter. Okay, so our average strength is 0.13, actually almost 0.14. We are getting close to 0.2. After 0.2, we can assume we started overtraining. Of course, this would depend on your training dataset, but it is an indication according to the experience of this developer. It also makes sense because as the strength of the vector increases, it will override the other vectors. You see, since they are all floating point numbers, numeric numbers, the bigger numeric number is usually making ineffective the lower numeric numbers. This is how machine learning usually works according to the chosen algorithms. They are extremely complex stuff, but this is one of the, let's say, common principles that in the many of the numerical weights based machine learning algorithms. Therefore, it also makes sense. Okay, we are over 500 epochs at the moment. So let me show you the generated sample images. These are the sample images. We are already very similar, and the latest one is, you see, looks like getting overtrained. So let's check out with the script we have. Just hit the up arrow and hit enter, and you see we are now over 0.2 strength. Therefore I'm going to cancel the training, and now I will show you how to use these embeddings. But before doing that, first let's set the newest via file to generate better quality images. To do that, let's go to the let me find it. Okay, go to the Stable Diffusion tab in the settings, and in here you see SD via is automatic. I am going to select the one we did put. Let's apply settings. Okay, and then we will reload the UI. Okay, settings applied and UI is reloaded. So how are we going to use these generated embeddings? It is easy. First, let's enter to our textual inversion directory, and inside here let's go to the embeddings folder. Let me show you what kind of path it is. I know that it is looking small, so this is where I have installed my Automatic1111. This is the main folder, textual inversion. This is the date of the training where it was started. This is the embedding name that I have given, and this is the folder where the embedding checkpoints are saved. When we analyze the weights, we see the change it has. So I am going to pick 20 of them to compare. How am I gonna do that? I will pick with 200 per epoch, like this. Okay, I have selected 24, right click, copy. By the way, for selecting each one of them, I have used the control button. You can select all of them, it is just fine. Then move to the main folder installation, and in here you will see embeddings folder. Go there. I'm just going to delete the original one, and I am pasting the ones as checkpoints. So how we are going to use them? Just type their name like this. This is equal to ohwx in the DreamBooth tutorials that we have. And let's see. Currently it says that it is using 7 prompts, but this is not correct actually. It should be using just 2. Okay, maybe it didn't refresh. Let's do a generation. Okay, we got our picture. I think this is taking 7 length because it is also using the, okay, yeah. So okay, now fix it. Now you see it is using only 2 tokens. Why? Because now it has loaded the embedding file name, and our embedding was composed with 2 vectors. Therefore it is using 2 vectors. However, if this was not our embedding name, if it was just a regular prompt, if we go to the tokenizer, we can see it was going to take, let me show you, 1 2 3 4 5 6 7 8 tokens. You see each number is a token. This is a token, so it was going to use 8 tokens. But since it is an embedding name and the embedding is only 2 vectors, it is using only 2 tokens, because in the background, in the technical details, it has composed of 2 unique tokens, since we did set the vector count to. So for each vector a token is generated, and with textual embedding we are able to insert, we are able to generate new tokens, unlike DreamBooth. DreamBooth can only use the existing tokens. Okay, so now we are going to generate a test case with using xiplot. I have tested CFG values and the prompt strength. So from prompt strength, I mean that prompt attention emphasis and it is explained in the wiki of the Stable Diffusion of Automatic1111 Web UI. So you see, when you use parentheses like this, it increases the attention to word by a factor of 1.1. You can also set directly the attention like this. So I have tested with embeddings the prompt attention, and it always resulted bad quality for me, but still you can test with them. I also played with the CFG higher values. They were also not very good, but now I will show you how to test each one of the embeddings. So instead of typing manually each one of the name, I have prepared a public CS fiddle script. I will also share the link of this script, so you will be also able to use it. So the starting checkpoint is 400. So let's set it as 400. Our increment is 200. We have selected, and our embedding name is tutorial name. Okay, so let's just type it in here, then just click run, and you see it has generated me all of the names. I have names up to 5,000. I copy them with Ctrl C or copy. Then we are going to paste it in here in the XY plot, and in here select the prompt SR. Then we need to set a keyword. Okay, let's set a keyword as KW. Okay, test. It is not important. You can simply set anything here. Now I will copy and paste some good prompts. To do that, I will use PNG info, drag and drop. Okay, I have lots of experimentation, as you can see. These experimentation are from Protogen training with textual embeddings. It was also extremely successful for my face. Okay, let's pick from my today experimentation, which is under under here. Let's just pick one of them. Okay, now I am going to copy paste this into text to image tab. You see, when you use PNG info, it shows all of the parameters of the selected picture if they are generated by the web UI by default. Okay, so you see face photo of let me zoom in like this. Test P21, this is from my previous embedding, so it is currently 60 tokens. Now I'm going to replace these with my test keyword. They will be replaced with these, all of the tutorial training text, which are my embedding names and prompt SR. Okay, as a second parameter, you see now it is reduced to 55. You can try CFG values actually if you want, or you can try the prompt strength, prompt emphasis. To do that, just add another keyword here as another KW. Okay, and let's put it in as a prompt strength. Actually not var strength, but prompt SR. Okay, and replace it with 1.0 and 1.1, for example. So you will see the results of different prompt emphasis, attention emphasis, as explained here. You can test them. You can also test the CFG values. It is totally up to you. Do not check this box because you want to see the same seed images. Actually, since these are different checkpoints, you are not going to get the same image. By the way, when we use the command argument in here, let me show you. When we use X-formers, even if you use the same seed, you will not get the same image because since this is doing a lot of optimization, it will not allow you to get the exactly same image even if you use the same model and the same seed. And also there is one more thing. Actually there are two more options if you have low VRAM. Let me show you. So in command line arguments of the wiki, if you search for VRAM, let's see, like this, you will see there is max VRAM, medium VRAM, and low VRAM. So if you also add these parameters to your command line arguments like this, let me show. Okay, met VRAM and low VRAM, it will allow you to run the web UI on a lower VRAM GPU. And with low VRAM and met VRAM, you can still generate images with very low amount of GPU. However, when you use low VRAM, it will not allow you to do training. So you can add met VRAM to your command line argument, and this will allow you to do training, textual embedding, textual inversion training on a lower VRAM having GPU. Okay. Okay, now we are ready. I'm not going to test the strength, so I'm only going to test the different embedding checkpoints. Okay, draw legend, include separate images, keep -1. Okay, we are ready. I'm not going to apply restore faces or tiling or high resolution fix. And okay, so let's just click and see the results. Oh, by the way, to get a better idea, I am setting the batch size 8. So in each generation, it will generate 8 images for each one of the embedding checkpoint. Okay, let me also show you the speed. So it is going to generate 25 grids because we have selected 25 checkpoints, and each one will be 8 images. Therefore, it will generate 200 images. Currently, it shows speed as 5.73 seconds per iteration. Actually, per iteration is currently 8 images, 8 steps, because we are generating 8 images parallelly as a batch. Therefore, it is actually 8 times faster than the regular one single image generation. Okay, since it was going to take 1 hour and it is already 3 a.m. and I want to finish this video today, I am going to show the results of my previous training with exactly same dataset and exactly same settings, and you are going to get this kind of output after generating grid images. It is actually let me see, 90 megabytes. So you see, these are the different checkpoints, as you can see, and from these images you need to decide which one looks best. For example, I have picked in this example test P 24 00 steps count, which means from 10 training images 240 epochs, and I have generated a lot of images from this epoch, and actually they are the ones that I have shown in the beginning of the video. These ones, so these ones were generated from the test P 2400 steps. As you can see, also the name is written on the images description. And show me one of the example and see how good it is. It is a 3D rendering of the person we did train it, and you see the quality. This is the raw quality. I didn't upscale it or did anything, and it is just amazing. Let's just upscale it and see how it looks in the bigger resolution. Okay, to do that, let's go to the extras tab, and in here I will drag and drop it. One moment. Okay, this image. Okay, and then I am going to use as RGAN, RSGAN for X plus. I find this the best one. Actually, you can try also anime for this one, and let's just upscale it 4 times. Okay, upscale is done, and look at the quality. It is just amazingly stylized quality, and these are the original images. You see how good it is. It is exactly same person and 100% stylized as we wanted. If we wanted some artist to draw this, I think the artist will draw as good as only like this. And I also didn't generate too much images because I had little time. I have been doing a lot of research experimentation to explain to you everything in this video with as much as possible details. Now, how you can combine multiple embeddings in the single query? Let's say you have trained it on multiple person, multiple object, and you want to use them, or you have trained it multiple styles and you want to apply them in the same query. It is just so easy. All you need to do is just type the names of them. So if you add here like this, and if you add this one, they will be used both. Since these two are using the same tokens, their strength will be applied. Both of their strength will be applied. Both of their weights and vectors will be applied. But if they were different embedding file, both of them would be applied. So this is how you use embeddings in the text to image tab. Hopefully I plan to work on and experiment on teaching a style and object and make another video about them, but the principles are same. It may just require to prepare the good training dataset. You see, this training dataset is not even good. The images are blurry, not high quality. The lighting is not very good. As you can see, this is a blurry image actually, and this is also a blurry image, and you will get the link of this dataset to see on your computer as well. However, even though these are not very good, the results are just amazing. As you can see, the textual embeddings are very strong to teach faces as well, and you can train you can do training on official pruned, or you can do training on Protogen, like a custom very good model, or ST 2.1. And the one good side of textual inversion than the DreamBooth is that, for example, I did DreamBooth training on Protogen and it was a failure. However, it was a great success for textual inversion. By the way, the grid images will be saved under the outputs folder inside text to image grids like this. When you do XY plot generation, and regular outputs are saved in the text to image tab like this. And this is all for today. I hope you have enjoyed it. I have worked a lot for preparing this tutorial. I have read a lot of technical documents. I have done a lot of research and experimentation. And please subscribe. If you join and support us, I appreciate it. Like the video, share it. And if you have any questions, just join our Discord channel. To do that, go to our About tab, and in here you will see official Discord channel. Just click it. And if you support us on Patreon, I would appreciate that very much. So far we have 10 patrons, and I thank them a lot. They are keeping me to prepare more better videos, and hopefully see you in another video.